This is video 19 for College Algebra. We're going to be looking at graphing rationals, and this is actually part one of two videos that we'll be talking about graphing. So we're going to be looking at how to find the horizontal and vertical asymptotes. We're going to use the table to help us graph, and then we're also going to find intercepts and the domain. All right. So first of all, looking at our vertical asymptotes, to find this, we are going to factor the denominator if necessary, and then our vertical asymptotes, which I'm going to abbreviate as VA or VA, those are located at the zeros of the denominator. So what we're going to do is just set that denominator after we factor it equal to 0 and solve. And so then those are also, and then we're going to find values that x can't equal that may or may not result in a hole, which we're going to be talking about holes in part 2, I believe. So that's how we find our vertical asymptotes. Horizontal asymptotes are a little more difficult. We compare the degree of the numerator and the denominators. All right, so there's three ways that we can be doing this. So the first one is if the degrees are the same. So if for example, if we have y equals 2x minus 7 over x plus 1, the degree of our leading coefficients, or the degree is the same, and so then we look at our leading coefficients. So we take the leading coefficient of the numerator divided by the leading coefficient of the denominator. So for this, we've got a 2 and a 1, so our horizontal asymptote would just be at y equals 2. All right. If the degree in the denominator is bigger than the degree in the numerator, the horizontal asymptote, or HA, is always going to be y equals 0. And then if the degree of the numerator is bigger than the denominator, then we simply just don't have a horizontal asymptote. So this page, talking about how to find our vertical and horizontal asymptotes, is going to be really useful when we're looking at graphing and how to graph. All right, so first of all, let's look at our horizontal asymptotes. Our degree is bigger in the denominator than it is in the numerator. We don't have any variables in the top. So this horizontal asymptote would be y equals 0. All right, and actually let's go ahead and we can graph that. So since it's y equals 0, I just put a little dashed line along our horizontal axis. Okay, our vertical asymptote. For that, we set our denominator equal to 0 and we solve. So this would be x equals 2. So here we're just going to write and draw our vertical asymptote. All right, to find our y-intercepts, we plug in 0 for x. So we're going to have 3 over 0 minus 2, and that's going to simplify to negative 3 halves. So our y-intercept would be negative 3 halves. Now to find our x-intercept, we put our function equal to 0. So here we're going to have 0 equals 3 over x minus 2. Now from here, we can cross multiply. If you think of this as being 0 over 1, when you cross multiply, we simply have 3 equals 0. Well, that's not true. So for our x-intercepts, we have none. And if you think about it, that makes sense because we've got an asymptote at 0. We can't have anything on that. Now for our domain, this is where it comes in handy knowing our vertical asymptote. So here we're going to have all real numbers, But again, x cannot equal 2. All right, and so now we can kind of graph our function. So look at your table on your graphing calculator or on Desmos, and we'll be able to kind of graph this a little bit. I know that my y-intercept is -3/2, so I know that my graph is going to be on these two sections of our graph. And I just kind of estimate a little bit, but use your graphing calculator to really know what points we're looking at. All right, and so there we've drawn our rational function. All right, our second example, we need to always factor first. Okay, so remember when dealing with rationals, factor first. It'll be very helpful to you. So our numerator factors to x plus 3, x minus 3. That's our difference of squares. And our denominator factors to x plus 1 and x minus 3. Now from here, we can cross off factors and simplify this a little bit more. So I've got f of x equaling x plus 3 and x plus 1. All right, but we also know that x cannot equal 3, and that comes from the factor that we crossed off. We would set that equal to 0, and that's how we get x equals 3, and that is a hole. So that's actually like a hole in our graph where our graph does not exist. And so because we cross that off, it's not a vertical asymptote, it's just our hole. So looking at this, let's look at our horizontal asymptotes. We have a x over x. So our horizontal asymptote is just 1 over 1, which is y equals 1. Our vertical asymptote, remember we put that denominator equal to 0 and solve. So we've got x equals -1. Okay, if we solve for our y-intercepts, we have 3. Our x-intercept is -3. And our domain is all real numbers, but remember it can't equal -1, and it also can't equal where our hole exists. All right, so let's draw in these things. Our horizontal asymptote is y equals 1. Our vertical is at -1. And then we can plot our intercepts. We've got one at 3 and -3. So this kind of tells us where our graph is going to exist. And then we know we have a hole at x equals -3. I'm sorry, at x equals +3. So let's go ahead and we can graph this side. And then when we graph this, when I get to that 3, and you can just kind of estimate, we actually draw a hole in our graph. Now your graphing calculator will not show this hole, but when you go to the table, it'll say undefined or does not exist. Same with Desmos. But when we graph them on paper, you'll need to put in that there is actually a hole that exists there. So this was just part 1 of graphing rationals, and we looked at vertical asymptotes, horizontal asymptotes, and we also touched a little bit on holes.